Now, the chairman, IEI Salem Local Center, to welcome the guests and the gathering. Please, sir.
So thank you, sir. Respected today's chief guest and keynote speaker, Dr. T. Sengol Rajan, sir. Our beloved Honorary Secretary, Dr. C. Dhaumani, ma'am. Distinguished committee members of both Tamil Nadu State Center and Salem Local Center. Engineer N. Armugam, sir. Members, Engineer Talk team members, friends, participants, and our IEI staff engineer T. Thiagu. Good evening and warm welcome to all of you. On behalf of the Institution of Engineers India, Salem Local Center, I extend a warm welcome to everyone. It is indeed a moment of pride and joy as we come together to celebrate the 30th anniversary of our esteemed IEA Salem Local Center. As part of this milestone celebration, webinars bringing together experts from various fields to share their insights and knowledge. It gives me immense pleasure to welcome our chief guest and keynote speaker, Dr. T. Sengol Rajan, sir, Associate Professor, Department of Electrical and Electronics Engineering, Trichy. We are honored to have some of Dr. Sengol Rajan sir's caliber with a vast experience and expertise, share his knowledge on the very relevant and timely topic of battery technology and battery management system for electric vehicles. Sir, thank you for taking the time to join us and enlighten us with your insight. This Engineers Talk series has been a platform for bringing together professionals, academicians, and students from various fields of engineering, perspectives, and stay updated with the latest advancements. As part of our 30th anniversary celebrations, these webinars hold special significance, and today's topic is crucial in shaping the future of sustainable mobility. I also take this opportunity to thank the participants from their continuous support and active involvement. Participants, your presence truly adds value to this initiative, and we hope that each one of you will benefit from today's talk and live with a deeper understanding of electric vehicle battery technology. With that said, let us now move forward to what we all here for. Without further ado, I once again extend a heartfelt welcome to Dr. Sengul Rajan sir and to all of you for joining us this evening. Also, I want to thank all of you for supporting us to make our 57th Engineers Day a grand success. Also, I thank all our sponsors at this moment. Thank you all. Thank you for your support and affection you are having on our IESLM local center. And let's have an enlightening session. Jai Hind. Thank you.
Thank you very much, sir, for welcoming the gathering and the guests. Now, it's my privilege to introduce the chief guest and the keynote speaker of today's webinar, Dr. T. Sengol Rajan. He has obtained BE in Electrical and Electronics and ME in Power Electronics and Drives from Annamalai University and Aruna Engineering College, Thiruvannamalai in 2003 and 2010, respectively. He has obtained PhD in Power Electronics from Annamalai University in 2018. He is presently working as Associate Professor in the Department of Electrical and Electronics Engineering at Kongunadu College of Engineering and Technology, Trichy. He has wide experience in teaching and industry. His research areas of interest are modeling, simulation, and intelligent control for Z resource inverters, derivatives of Z resource inverters, trinary source inverters, renewable energy systems, e-vehicles, Internet of Things, and sensor technology. He has published 26 international journals, presented 42 technical papers in various national and international conferences. He has authored 9 books and published 5 patents and 1 design patent. He has received 4 national recognitions for providing mentor support to projects exhibited at national level. He is a life member of Indian Society for Technical Education, New Delhi, member in International Association of Engineering, Hong Kong, fellow member in International Society of Research and Development, London, UK, associate member of Universal Association of Computer and Electronics Engineering, New York, and member in Institution of Engineers, India. With these words of introduction, I would like to invite Dr. T. Sengol Rajan to deliver on the topic battery technology and BMS for EV. Sir, please.
Good evening. Good evening, sir. Good evening, sir. Can I able to
Yes,
hear
sir.
my voice? Yeah.
Yes,
Good
sir.
evening.
Yes, sir.
Yes.
A very good
Good e-
evening, sir.
Yes, sir. Good evening. Good evening to one and all in this platform. Now I take immense pleasure in thanking Dr. K. Tangaraj, Chairman and Council Member, Dr. C. Davamani, Honorary Secretary, and the committee members, Dr. A. Kumaravel, Engineer K. Selvan, Dr. R. Sadish Kumar, and Engineer N. Arumugam for providing me this wonderful opportunity to deliver a special lecture on battery technology and BMS for electrical vehicle. Just a minute. Slide is not moving.
They're not audible, I think so.
Minutes, sir. Slide is not moving. A technical issue. Just I will correct.
Okay, sir. Okay.
Yes. Now I am focusing on going to focus on the batteries as well as how we have to take care of the battery, that is battery management systems. In electrical vehicle, a battery plays a vital role since because of its zero emission of harmful gases as well as how it is use of efficient energy. So that's why we have to take into care of that. So that is battery management system. We are, since it is been providing the necessary power. The electrical vehicle should not only provide long lasting energy, but it also provide high power. There are more number of batteries, that is among them, we are going to prove from the results, from the tabulated results finally at last, that is lithium ion battery is being most best suited for electric vehicle. The some of the batteries that is being available in existence is lead acid battery, lithium ion battery, nickel metal hydride battery. These are the most usely batteries for tractions. Then as well as among this lithium ion battery is being most commonly used because of its advantages as well as performance. Then I am going to prove from the tabulated results at the end. Then in the electrical vehicle, mostly battery capacity range used is 30 to 100 kilowatt hour. So the battery management system is being more important, and we have to take into account of battery charging, discharging rates, state of charge, that is called SOC, then state of health estimation, cell voltage, temperature, current. These are the parameters that we need to take into account in perspective of battery. So that's what battery management system is being required. Then here is the snapshot of the various batteries that we are being going to discuss. That is lithium ion battery, nickel cadmium battery, then zinc carbon battery, alkaline battery, nickel metal hydride battery, coin cell battery, lead acid battery, and a sealed battery. Then there is a chart that is been showing that yearly starts from 2018 to 2030. It is been proving that is the usage of battery is been increasing year by year. Then in 2030, it is been expected to be, that is 88.94% from this graphical chart which I have been displayed. Mostly the battery that is being used for electric mobility in 2030, it will be expected to be 88.94%. And for energy storage, Then consumer electronics, altogether it will be increasing in 2030 to be 88.94%. It is being gradually increasing. So we have to be focused on that battery management system. Then the next chart, it is been indicating about the global battery industry demand by regions. So in 2018, what are the various countries that is being using, like China, that is European countries, USA. So what are the countries that is being using the battery? The demands of that battery is been shown. Then for electric vehicle propulsions, lithium-ion battery is being used very well after the successful commercialization. In lithium-ion battery, there is three important parts. One is the anode, cathode, and the electrode. Not only lithium-ion battery, all the batteries been having the same three parts, including the separator. Then the lithium-ion battery, we have to focus mostly on the charging as well as the discharging process. Then first we will see about the lithium-ion batteries' its futures. Lithium-ion battery compared to other batteries, it is been more popularity because of the electric light motor vehicles, then high power to weight ratio, good high temperature performance, excellent specific energy, and low self-discharging rate. Lithium-ion battery, compared to other batteries, it also has the ability to hold a full charge over time. Then lithium-ion battery have a long cycle life. It support higher energy cost, exceptional power efficiency, longer service life, and eco-friendliness. Lithium-ion battery is discharged up to 90% of total capacity. It gives a better mileage compared to other batteries due to lightweight. Then lithium-ion battery is having better propel the vehicle and can discharge faster and can supply more power compared to hybrid electric vehicle. Then next, moving on to lead acid battery, it has been in the development phase and it's been advancing compared to lithium ion battery. Lead acid battery have low energy density. It is easier to recycle. About 95% of the content of the battery can be reused. Then lead acid battery do not discharge more than 30 to 40%. That is the difficulty. So that is the reason, one of the reason for damages lead to lead acid battery. Then moving over to nickel metal hydride battery, there is two poles. One pole, it is been of nickel alloy, and the another pole is been about nickel oxyhydroxide with the electrode of potassium hydroxide. Then it is usually slower to charge and discharge the battery. It contains less power per weight, then takes longer time to charge the battery. It can deteriorate faster also. Then compared to life cycle, over 3000 cycles it can be used and it is environmentally friendly. The voltage of nickel metal hydride is around 1.2 volt. Then coming to ultra capacitor, or otherwise we will be calling it as a super capacitor. It is holding the static energy. Then it has provide higher currents and higher specific power. It won't have any heating problems compared to other batteries. Ultra capacitors can do millions of charging cycles, then multiple applications, for instance, in buses, trains, and microgrids. You can be able to continue the improvement as well as over time that the changes cannot be done in other batteries. Then, as I said in the beginning, I made a tabulations based upon the literature surveys of all the batteries that is being used in existence: lithium-ion battery, lead-acid battery, nickel-cadmium battery, and nickel metal hydride battery. Comparing, if we say exactly the parameters for battery, there are 21 nominal parameters are there. But I have taken the more important parameters, around 6 to 7 parameters, and I have been made a tabulations comparing the nominal voltage, energy density, power density, then lifespan, that is the services cycle, then the discharging rate, charging temperature, and the discharging temperature. I have taken the most important parameters among the 21 nominal parameters and compare to that all the 4 batteries that is being used in existence. It shows lithium-ion battery is significantly better than other types of battery in terms of large cycle life, which is a key to long series of electrical vehicles. Lithium-ion battery is also composed of eco-friendly materials and has high safety level. Therefore, concluding, lithium-ion battery becomes more popular power supply for electrical vehicles. Then that's why the reason that you've been heard about that Lucas TVS Limited, which has been in Padi as well as in Pondicherry and around in Haryana and also in other countries. They have been signed with a central government that to start up for manufacturing the lithium-ion batteries alone for 3 cores in Chennai in Sriperumbudur area. It was being signed an year before the last year. The reason of the lithium-ion battery has been more popular. Then in Chennai, Salem also, the Birds India Corporation, there is one company. They have been having a tie-up with Anayana City, the industry center, and they are been manufacturing this lithium-ion battery also and concentrating more on this lithium-ion battery compared to other batteries since it is being more eco-friendly and having more advantages. So these 2 companies are been concentrating more on lithium-ion batteries. Those who are being want to know work on lithium-ion batteries, you can approach this Birds India Corporation that is in Salem as well as Lucas TVS Limited. They have been signed an MOU. Then you can send the students also for internship and other project works to these 2 companies. Those are being want to work in lithium-ion batteries. Then here I have been given the lifespan of electrical vehicles. For it is around 8 years, or you can say in kilometer it is 160 kilometer. Then the nominal voltage of lead acid battery is 2 volt from 12 volt, and lithium ion battery it is 3.3 to 3.7 volt. Nickel metal hydride battery is of 1.2 volt. So comparing, lithium ion battery is the highest voltage range 3.3 to 3.7. Then this has been about the safetyness of the, one of the important parameters of the battery is safetyness. So because of that safetyness, we have been concentrating on battery management system. Then another parameter is cost. The major cost is that is for battery we will be spending. Then performance, we have to analyze the performance. Then specific energy, that is a capacity in weight, WH per kg. Then the specific power also you will be concentrating, that is the torque. Then compared to the industrial chain, starting from step 1 to step 6, there is several processes that is being carried out: material processing, then cell production, module production, package assembly, then vehicle integration, recycling. So these are the various processes that is being in the industry that is being carried out in manufacturing of the batteries. Then this is about the recycling of the battery process: recycle, reuse, refabricate, and resell to improve the sustainability. Everywhere we are been saying that the sustainability is so sustainability development. So we have to focus on that also in the battery. So that is how it can be refabricated or reused. That also been more important. The next we are being going to focus on that the second part, that is battery management system. Battery management system is also being more important because of the performance parameters we have to monitor. The most important parameters is the controlling the charging as well as the discharging profile. We will be using the laptop as well as either the battery or the laptop or the mobile phone. We will be, since we have to, that is the thing is we have to charge a plug-in once it is been detrained completely. Or that is, or else we have to maintain 20 to 30% before the battery gets getting detrained. We have to plug in. So, but we are not, if it is 50%, 70% also, we are simply plug in, then the life cycle is been very less. So that is, the system is we have to use before 30% detrained, before it gets completely detrained. Then only the life cycle of the battery will get be improved. Then we can that is we can go for that is maximum usages. Then only the lifespan of the battery will be a maximum. Then it protects the battery cell from abuse and damages. It extends the battery life as long as possible, then making sure that battery is always ready to be used. So we should have a avoid, that is ensure that risk of damaging the battery should be minimal and usage of the battery is been the maximal. Then one of the important parameters we have to ensure is safe charging and discharging. That is, we will be calling it as a state of charge, that is SOC. SOC, what is SOC means? It is defined as the present capacity of the battery expressed in terms of its rated capacity. It provides the current state of the battery and enables the battery to be safely charged and discharged, and also provides the suitable battery life enhancement. Then this SOC will be involving in measuring of the battery voltage, current, temperature, and as well as the other information that we have to take into account. Then here is a flow diagram that is been illustrating what are the parameters we have to take into account. That is, regarding the battery, we have to take into account of voltage, temperature, current. Then the output side, that is state of charge, state of health, then as well as the fault status, whether there is any fault status is being indicated or not. So these are the parameters we have to take into the input side of the battery as well as the output side of the battery. Then coming to battery management system, the entire focus, the functioning, the data acquisition, state of charge estimation, charge control, discharge control, fault diagnosis, health management, thermal management, cell balancing. So these are the parameters we have to focus if you want to have a good battery management system. Then this a simulating diagram that is been illustrating here. That is what are the parameters we have to take into account. The same what I have been repeated in the previous block diagram. Then it's been about the measurement block, the cell voltage, battery current, battery temperature. These are the points you have to take into account while considering the simulations, ambient temperature. Then that value you have to give it in digital values. Then capability estimation block, that is we will calling it as a ECU, electronic control unit. Here SOC, state of charge as well as state of health, we have to determine this. The next cell equalization block. The cell equalization block is been to maximize the usable battery pack capacity as well as the lifespan. Normally it is 50%, 15%. The next thermal management block. This will take into having the control of monitoring and controlling the battery temperature. If battery temperature rises, it will harm it. Or if it is very high also and very low also, it is we have to take into account. So we have to maintain the ambient temperature of the battery. Then this the entire battery management system, how we are being taking into how the batteries are being connected, how the charging is been taking place and discharging is been taking place, where we will be concentrating more on state of charge, state of health, as well as the thermal management. We have been taking care of three important parameters in the battery management system. One is SOC, state of charge, state of health, then thermal management system, the temperature of the battery. Then all these three parameters is being fed into controller area network, that is the bus controller, where the inputs is being given. Then according to that, the scan protocol will take into account of the decisions of the battery management system. Then here in BMS, four important parameters is being more important. Fourth thing has to be monitored. One is parameter estimation, that is SOC, SOH determination, communication, monitoring, and distributing the parameter value to a controller area network for cell balancing. And another parameter is data storage. It will monitor and diagnose if any errors or risk. It will send a warning signal to the driver. Another one is control, that is control over the battery voltage, current, temperature signals, and controlling to achieve the cell balancing. Then the fourth one is diagnosis, records pack level, individual cell signals, stores data related pack cycle for analyzing the life cycle history of the battery as well as the memory in cloud. So these are the four important parameters or the methodologies we have to focus on battery management system. Then these are the various text discharge test, then Coulomb counting, then OCV, EMF, linear model. So these are the techniques where you can use the battery management system depending upon the various applications. Suppose if you are taking that is EMF technique means it can be applicable for lead as well as lithium ion battery. So depending upon the battery which you are being going to choose, so according to that we have to choose the technique. And if you choose that corresponding technique, what is the advantage and what is the drawback I have been listed. Then the most advantage of the battery management system is the SOC, you can calculate, SOH, you can monitor, then power management control, discharge charge control, then thermal management, cell balancing equation, current and voltage monitoring, battery protection, data acquisition, then fault diagnosis, and also you can have various other assessment also. And this is a block diagram that is been illustrating the entire battery management system, what we have been discussed previously, how the parameters is being estimated, and how it is being communicated through the controller area network. Then if you provide maintaining the PMS in a very good manner, so you have to focus on hardware part also as well as the software part also. What are the parameters that comes under hardware part? What are the parameters that comes under software? Under hardware, safety, security, sensor system, data acquisition, charge control, communication, thermal management. Then under software, state of charge determination, state of health determination, cell balancing, fault detection, user interface. So all this both is being, this all comes under. Then under software part, SOC, SOH is the capability assessment. These two be more important in the software part. Then this being about the manufacturer specifications regarding the batteries. Then this being about I have taken one electrical vehicle projections for projections. Then how the electrical vehicle segment it is been growing, the annual growth, then electric vehicle penetration state, then total number of e-vehicles that is used in 2025, expected to be in 2030 and in 2030. These are the projections taken from the survey paper. And this is also about the charging demand that is being required in 2025, expected to be, and in 2030. Then this being about the type and number of public charges in 2020 and 2030, about the public charging. Then the functioning of the BMS. The BMS has been functioning of four parameters. One is under measurement, we will be concentrating on voltage, current, temperature. Under control, we will be concentrating on protection, balancing, thermal management of the battery. Under evaluation, we'll be focusing on SOC, internal resistance, one of the important parameters of the among the 21 nominal parameters of the battery. Then the capacity, state of health we will be evaluating. Then communication, sensor, measurement data, configuration commands, and the request. Then in the battery management systems, commercially available batteries, we will be focusing about the SOC. Then the another important parameter is we have been come across SOC, state of charge, state of health, and another important parameter that is DOD, that is depth of charge. How far we have been detained the battery, either that is completely 0% or it is been around in the order of 30 to 40% only. So that is the another important parameters. Then this has been the research area. I have been taken on switched capacitor converter. Then in the switched how this switched capacitor converter is being improved on concentrating all the parameters. Then finally, there is an advantage that is compared to conventional converter. It is lower voltages, highest voltage to the cell with the lower voltage value we can be able to obtain. That is the balancing time also become more significantly shorter if you concentrate on BMS for a conventional converter compared to the BMS monitored converter. And this modes state of charge and the state of charge on if it is operated with the state of charge converter, how it is the improvement. Then finally the state is the state of durations that is been monitored in case of SOC, and it is a detailed manner. This and all focusing on research about the SOC. Then compared to the same, the another converter that is double tiered switched capacitor. And here it is improvement that DTC uses 2 levels capacitor for energy reductions. And finally, that is reduced major hardware part is being reduced. Then one of the converter is that is zero current switching. Zero current switching, that is ZCS. In this also, you can be able to balance the cell voltage, and sudden changes in the current also you can be able to avoid, and sudden switching also you can be able to avoid if you focus on BMS and concentrate on SOC as well as SOH. Then more if you want to concentrate, you can concentrate on depth of discharge also, DOD. Then here also the focusing area on research I have been given. That is okay. Finally, what I am saying is among the battery, we have been listed 4 batteries. Among the batteries in existing, lithium-ion battery has been most suited, and they are also eco-friendly. The nominal cell voltage is around 3.32 to 3.7 voltage. So those who have been want to use battery for e-vehicle, concentrate on lithium-ion battery as well as for usage as well as for research purpose, lithium-ion battery. Then if you want to have a battery management system for batteries, you focus on SOC as well as SOH and DOD, depth of discharge. This is the thing I want to conclude finally. Thank you. So thank you, sir. Thank you, sir. Hello, sir.
Yes, sir.
Yes, thank you, sir. Thank you.
Thank you very much, sir.
Okay, sir.
And I request the participants to raise any queries if they have in the topic.
So one question in the chat, sir. What is a battery cycle?
What's it?
What is battery cycle?
Battery cycle is that is the usages, sir. For how long that is we can be able to recycle it and usage. The usage, the time duration. In simple words, we will say the time duration of the battery. How long we can use? How long the battery can be recharged and it can be used. So that is the battery cycle.
Battery cycle in sense it is charging and discharging.
Discharging, that is
yeah.
one cycle. That is how
One
far we
cycle.
can use it. Yes, sir.
Yeah. Thank you, sir.
How many
Thank you.
cycles? Yes.
So suppose I have another doubt.
Yes, sir.
Charging and discharging. Now, whether suppose I am charging it not to the 100% charging.
Yes, sir.
Suppose I am intermittently charging. Now, whether it is to be considered as one cycle or only if I charge it completely till 100%, it is considered as one cycle.
Sir, if it is, that is, we are being used, it is suggested to use, charge it 100%, then use it. Then only you can be able to benefit it. Also, when you have to, that is again charging means once it is been at the time of 30% itself, we have to charge it for next cycle. Don't wait for 0% declaration.
Okay.
If it is 0% means the lifespan will be reduced. That's what it is being suggested.
Okay, sir. And as well, some are saying that we should not charge it till 100%. We need to stop it around 80 plus.
Not like that, sir. It is from the survey, from the various survey, it is been saying that that is you can charge up to 100% and you can use it up to till 30% the battery is discharging.
Okay, sir.
Not waiting for 0%. Then also we used to simply keep on charging. The laptop we will be as academicians as well as in industry person, simply without knowing whether there is fully charged or fully discharged, will be that is just we will be plugging and they will be going off.
Exactly.
So that we have to check it over. That is whether it is 100% means we have to unplug it.
Yeah. So once
yes, sir. Then only the life cycle will be more, sir.
More. Yeah. Okay. Sure, sir. Then thank you very much.
Yes, sir.
Sir, one more question.
Good evening. Yes, sir. Good evening, sir.
Yes, I have one question, sir.
Yes, sir.
For converter side, you told I think 3 key converters: switching capacitors, DTSC, and ZSC, sir. Other than these 3, any other converters we can use for EV, sir?
EV, we can go for that is even Z source converter also you can go, sir.
Okay, sir.
Z source converter, trinary Z source, where you can be able to reduce the switches and you can use it for e-vehicle purpose, sir.
Okay. Sir, another question, sir.
Yes, sir.
Sir, in Salem, what is the company name of?
Bots India Corporation, sir. You can Google it and see, sir. Bots India Corporation.
Bots.
Yes, sir. That is a very good company. They have been manufacturing the lithium-ion battery alone, sir.
Okay, sir.
Those who are been in academic group also, you can have a industrial visit and you can send for project work also, sir.
Okay, sir. Can you repeat the company name once again, sir? Sorry.
Bots India Corporation.
Bots India Corporation.
Yes,
okay, sir.
Yes, sir.
Okay, thank you very much, sir.
Thank
nice
you,
section.
sir. Thank you, sir. Thank you, sir.
Sir, one more question, sir.
Yes, sir. Yes, sir.
Sir, you explain only 6 parameters in the battery.
Yes, sir. Yes, sir. There are around 21 parameters, sir. But UG students, they will be studying in detailed manner the 21 parameters. Among the 21 parameters, I have taken the important parameter alone for comparison, sir.
Okay, sir. Sir, while which battery is the best capacity tends to have the long life, sir?
Sir, as per the survey, it says lithium-ion battery, sir. The nominal voltage is around 3.2 to 3.7 compared to other batteries.
Okay, sir. One more last question, sir.
Yes, sir.
If a single cell get damaged or any kind of failure, the entire battery will leads to failure. Is the case available, sir?
If it is connected in series, if the battery is connected in series, we can also go for replacement also, sir.
Okay, sir. Okay, sir. Thank you for the wonderful presentation, sir.
Thank you, sir. Since it is limited to half an hour, I could not be able to go in detailed manner, sir. So that's why I simplified. Sorry for going in detailed manner, not going in detailed manner. If it is a seminar or means I can go in detailed manner, sir. So since it is webinars are restricted to half an hour, so that's why I reduced the way of my presentation.
Yeah.
Okay.
Okay, sir. Thank you very much for
Thank you, sir.
educating us all on the battery technology and BMS for EV. Thank you very much. And now I would like to invite our Honorary Secretary of IEI Salem Local Center to propose vote of thanks. Madam, please.
Thank you, sir. Sir, am I audible, sir?
Yes, ma'am. Yes.
Okay. Thank you, sir. Most respected our chief guest and keynote speaker, Dr. T. Sengol Rajan, sir. Respected our chairman, Dr. Tangaraj, sir. Respected members, fellow engineers and students from various organizations. Good evening to all. It's my privilege to propose vote of thanks in this great occasion. Engineers Talk, a weekly online lecture series. This is the 45th webinar. Topic is battery technology and battery management system for EV. So on behalf of IE Salem Local Center, I would like to express my deep felt thanks to our chief guest and keynote speaker, Dr. T. Sengol Rajan, sir, as a Associate Professor, Department of EEE from Kongunadu College of Engineering and Technology, Tottiyam, Trichy. Sir, you have given much important insights about the battery technology and management system, battery management system for EV vehicle. Many thanks for accepting our invitation and gracing this occasion with your warm presence, sir. Thank you so much. My sincere thanks to our beloved chairman, Dr. K. Tangaraj, sir. Always hard worker and supporting to organize all the IEA activities. Thank you so much, sir. I would like to convey my sincere thanks to Dr. R. Shankar, sir, HOD EEE, Kongunadu College of Engineering and Technology, for introducing our today's chief guest, Dr. T. Sengol Rajan, sir. Thank you so much, Dr. Shankar, sir. I extend my sincere thanks to our engineers stock team members, Dr. R. Satish Kumar, sir, Dr. A. Komaravel, sir, Engineer N. Armugam, sir, Engineer K. S. Selvam, sir, for spending their valuable time and rendering the needed support always. I convey my sincere thanks to Engineer N. Armugam, sir, for his kind cooperation and support always for our all IEA activities. I record my sincere thanks to Mr. Thiago for his valuable support and organize this webinar successfully. I also wish to express my gratitude to all the eminent engineers, fellow engineers, professor and students for their kind cooperation to make this event successful. Once again, thank you all for making this event very success. Thank you so much. Thank you, sir.
Thank you, ma'am. Thank you.
Thank you, sir. Thank you.
Thanks a lot, sir.
Thank you, sir.
Thank you.